Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
Know your rights. Use them responsibly. Lead SA.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
Chris, why are you laughing?
Just because of the chaos, really.
What chaos? We're very organised here.
Very organised. Good morning. It's lovely to be here. It's lovely to be here and see everybody in the flesh. Because it's amazing. When we talk to each other down bits of cable, everyone looks not how you imagine. Do you know what I mean?
It's true.
Because it's actually 3 and a bit years since we started doing this stuff together.
Absolutely. And Aki is obviously uglier than you imagine.
How did you imagine Reedy to look?
No, because we first met a while ago, but it was a little while ago, and you sort of revised the mental picture of what...
This is the Naked Scientist!
Oh my God, he's actually stripping off. And it's not a good sight.
No, put your clothes on. Like, you see what I have to deal with. But Chris, you're not alone. You've brought Ben with you.
This is Ben Valsler, who is the producer of The Naked Scientist that we make in the UK and for the rest of the world on the podcast. And he is also the presenter of Naked Astronomy, because we realised when we were running the show how popular astronomy is and space science. And we decided to make a whole programme just on its own right about space science. And so there's a monthly programme now, Naked Astronomy, which people download just as a podcast. And Ben sets it up and runs it. So here he is. You got the Naked Astronomer in the
Thank
studio.
you very
too.
much, Ben. Can I hijack him? Can he stay for the rest of the show if we get some astronomy-related questions? Welcome, Ben.
Well, I would be delighted, yes. I should point out I'm not an astronomer. What we wanted to do with Naked Astronomy was find a way to speak to astronomers in such a way that the normal person would be able to understand, because there's a lot of really good information, really rich information, if you already know a lot of the background. And my background's actually in zoology, so I'm just like the people listening at home. I'm really interested, but I know very, very little. So I'll quite happily have a go.
And, we're looking forward to that.
And hopefully I'll have picked up a few bits that I can help people out with.
And just about the Naked Scientist in Britain, I just find every time that Chris is busy, which doesn't happen often, and he can't join us, I meant him not joining us doesn't happen often, we get emails and SMSs. Everybody wants to know, when is he coming on? Can't we extend the show? And if it's so popular here with our Cape Town and Johannesburg and Gauteng listeners, it must be massive back in the UK.
I think it seems to be bigger here, actually. The thirst for knowledge here is incredible. It's really inspiring. Whereas back at home, I think that there's a lot of science on TV. It may not be quite as in-depth and quite as precise as the stuff that we do, but I think people feel that they've probably got enough science. Whereas here, the enthusiasm from the audiences here is wonderful.
You're going to have a great time at St. John's. Now, Aki, you have a question?
Well, actually, I've got two, but the one I'm going to ask in the next hour because it's kind of green tip related. But the first one is, I read some interesting research that has said these jet airliners that are flying all over the world transporting passengers, they're saying that because of these jet airliners, there is more rainfall in certain of these areas. Now, is this a plausible argument that we have more air flight and air transportation taking place, that there's more rain in those areas?
The answer is yeah, absolutely. The paper you're referring to is published this week in the journal Science, and I was reading it just last night. And what they've actually discovered is that there's a phenomenon. It was first spotted about 50 years ago, and they're called hole punch clouds. And they're also called canal clouds because you see these clouds and they have literally a hole in the cloud.
Wow.
And in some cases, these holes can be 100 kilometres long. And hence they look a bit like a canal. And everyone said they seem to be married up with aeroplanes, but they couldn't prove it. And now there's this group in the States who have done a really thorough analysis, and they've looked at 92 examples of these clouds seen from satellites to spot where the holes are. And then they've gone to data of where aeroplanes have flown on the same time as the satellite pictures were taken and married up the position of the aeroplane with these holes in the clouds, and shown that there is a really strong correspondence between an aeroplane flying through that patch of cloud at that time to trigger this hole. So what causes the holes? Well, it's really ingenious. They've actually done a model in the paper which explains why it happens. So when you put water vapour up into the air to make a cloud, bizarre as it sounds, water does not freeze until about minus 40 degrees C. Instead, it just hangs around at higher temperatures than that as supercooled water. So when these aeroplanes go flying off of the runway or coming into the runway and they're taking off or landing, they will pass through a zone of the atmosphere where the temperature is about -20 or -30. So the clouds there contain liquid water. It's super cooled, but it's not ice. But as the aeroplane goes through, because of the way that aeroplane wings and propellers work, they create little pockets of low pressure. So they're expanding the air over the wing or over the propeller tips. And when you expand a gas, as you know, if you take your deodorant and spray it in your armpit,
Yes.
it feels cold because you're expanding a gas. And when you expand a gas, it's doing work against the atmosphere, therefore the temperature must drop. So the aeroplane makes the temperature drop around itself. And it can actually make the temperature drop by 30 degrees.
Wow.
And this is enough to trigger some of that super cooled water in the cloud to turn into ice crystals. And so you actually make ice crystals in the cloud, which are heavier, so they steal water from other bits of the cloud, making even bigger ice crystals, and they begin to fall as initially ice, but then they'll melt on the way down and turn into rain, and where they came from leaves a void or a hole in the cloud. And that's what these hole punch clouds are.
That's fascinating.
And the interesting thing is that because the aeroplanes will be at that sort of altitude, about 3 kilometres up, within about, 100 kilometres of the airport, these effects will be manifest in a radius of 100 kilometres around the airport. So you'll see more rainfall or snowfall in that 100-metre ring around the airport than in other places. And although the global impact of this is likely to be quite minimal, really, there is an important environmental point, which is that the clouds which are over the Arctic, the polar regions, Antarctica and the Arctic, they're actually really susceptible to this effect because of the dramatic temperature changes there. And if you make holes in clouds, you very strongly influence how much radiation comes through the cloud from the sun, because clouds actually do a very important job, because they're shiny and reflective, of beaming radiation back into space. And therefore, if you have holes in them, you get more light coming in, and therefore more heat coming in, so you create local hotspots. So it can have a climatological consequence.
Thank you for that.
Thank
That was
you very much.
fascinating.
Thanks,
Cheerio.
Ike. I have
question.
an email here, indeed. I have an email here from Jabu. Jabu wants to know, is it possible to influence IQ before birth? And while the child is in the womb, can you do something to make the child more intelligent? It's a very long email, but that's the message.
Well, it's interesting you said that, because there is this whole idea of people sort of playing music to themselves when they're pregnant, the idea being you stimulate the baby. And there was some research published in the last couple of years where they've shown that babies are born with an understanding and an appreciation and an affection of their mother's accent, because a lady in Germany got a big group of mothers who were German and a big group of mothers who were French, and played the babies sounds which were either the way that French people speak, which is you put the intonation in a different part of the word than German people, and the babies born to French mothers responded much more dramatically to the way the French people sound if they were French, and the German babies to the German mothers. So that there was, and the babies also adapted their cries in the same way. So the babies will cry mimicking their mother's accent. So in other words, this is newborn babies, so they must have learned this in utero. So there's definitely learning taking place when a baby is inside the mother. So the baby is definitely responding to that environment. But the degree to which it will influence ultimate intellect isn't known. But then it's worth bearing in mind that obviously a baby is very, very, very rapidly growing when it's inside its mum. And if the mum has some kind of health problem or is not well nourished, and therefore the baby is not well nourished because the mum isn't, this could have an effect on the tissues that have got to grow the most inside. And the brain is one of the most rapidly developing tissues inside the mum. So if the mother is healthy and doesn't take drugs, and especially alcohol, because alcohol can have a very dramatic effect, and if the mum stays free of infection, because there are some infections which can go into the nervous system of a developing baby, in the absence of those factors, then you should have a healthy baby.
All right, we're taking your calls, 021-446-0567, 011-883-0702. The SMS line is up and running, 31702 and 31567. You have a double treat this morning. It's not just the Naked Scientist, but the producer of the Naked Scientist, Ben. And you said you studied zoology, and you're answering questions mainly about astronomy. So if you've got any questions related to those subjects, like Pierre in Braamfontein, you want to ask something about astronomy and the temperature of space. Good morning.
Good morning. Actually, I have 3 questions, if you don't mind.
I do mind, but anyway.
All right. The first question relates to space, obviously. If you removed all particles, right, if you have an absolute vacuum, you removed all particles and there was no ambient energy around, what would the temperature of that absolute vacuum be? The second question relates to if you implanted like a fertilized human embryo in another animal's uterus, would the embryo grow?
Mm-hmm.
And the third one is
Are you writing these down, Ben?
I'm writing these down.
Good. Sorry, Pierre, carry on.
Yes.
All right. The third one relates to. Okay, I'll leave you with us.
Oh,
Okay, and Pierre, you're not allowed to phone us for the next 3 weeks. Do you hear?
No. Right.
You're mortgaging up your time.
Ben, shall we start? Oh, okay. Sorry, Chris.
Well, yeah, I can have a go at the temperature of space. It depends quite a lot on whether you're in sunlight or something like that, because without particles of air or something like that around you to bounce into you, then it's going to be very, very cold. But the other thing about being in space, of course, is you don't have those particles of air to help diffuse the radiation that's coming from the sun or from other stars. And so actually you can burn quite badly, even though the temperature's very cold. There's also radiation left over from the Big Bang, which has now been sort of stretched out over time to be very low wavelength radiation. So even when there's an apparent absence of everything, it won't be absolute zero. There will be a baseline temperature, which I think is a few degrees above absolute zero.
Yeah, it's a fraction of a degree above absolute zero. So, I mean, what Ben's saying is, he's absolutely right. If you've got what we call temperature is the average energy of particles. So if there are no particles, in theory, if you stuck a thermometer there, you wouldn't record anything. But at the same time, if you have incident radiation from the sun, it can be blisteringly hot. And the reason that the astronauts who go on the moon and so on have these very sort of reflective masks and very tough sort of outfits, these spacesuits, is because the radiation would be lethal within a very short space of time, because there's no magnetic field on the moon or out in orbit around the Earth in order to protect you. So the International Space Station has to fend off this onslaught of the solar wind, which is all these charged particles and radiation, and the fact that the bright light coming from the sun, including ultraviolet light, is totally unattenuated by any atmosphere, because we have an ozone layer to screen out a lot of that short wavelength ionizing radiation, which is not there in space. So if you can see a star nearby like our sun in space, you'd be getting quite badly burned.
And the embryo... Sorry, Ben?
Well, I was going to say, this also means that when you go from being in sunlight to being in shadow, the transition of temperature is enormous and very, very quick. And that poses quite a large problem for building satellite components, because they're going to expand in the heat, they're going to contract in the cold. And these temperature changes happen so quickly that you really need to design things that you're going to send into space very, very carefully to take that into account.
And they do it by dunking them in liquid nitrogen. So you build your satellite, you have it at room temperature, and then drop it into a big vat of liquid nitrogen at minus 200 degrees. And this tests these things in terms of their ability to withstand that very cold temperature, both electrically, because you've got to have a battery that's capable of operating under much lower temperatures than normal, but also in these very high temperatures when the sunlight's incident on them.
And that question about an embryo transfer?
Well, the thing is that there's something clever going on when a person gets pregnant, because normally if you take a piece of tissue from one person other than your identical twin and you put it into another person, the recipient person's immune system recognises this is not part of me, and it mounts an immune response against that tissue. But when a woman becomes pregnant, half of the genetic material in her baby are not her own. It's the genetic material of her partner.
Yes.
Yet, although that tissue is in close contact with the mother's bloodstream because of the placenta, which is collecting nutrients and oxygen from the mother's blood supply and dumping the baby's waste products into the mother's blood supply, despite that very close contact, there is no immune rejection. The immune system does not attack the baby tissue. So, in some way, the baby is encouraging the mother's immune system to be regulated. If you take very, very dramatically foreign tissue, though, from an animal and put it into a person, or vice versa, it doesn't work, and that's probably because the cells that form that special interface, the placenta, between the baby and the mother, they carry surface markers that do this important immune regulation task, and they are different for an animal and a human. So there would be some kind of dramatic rejection going on, and the animal would not be able to implant in the first place.
That's a huge, huge relief. Let's go to Luke. Luke in Roodepoort. Good morning to you, Luke.
Good morning.
Hello, Luke. You're 7 years old, am I right?
Yeah.
And you have a question for the Naked Scientist.
Yeah.
Go for it, my boy. Ask your question, my darling.
what colors can the dog see?
Okay. Yeah. Hi, Luke. Good to have you on the programme. Dogs can see in two main colours, where humans have cones in their eyes which are capable of discerning three different colours. So we have cones that detect and distinguish red and green and blue and yellow. Then dogs have only two different colour cones. So that means that they have a restricted colour vision, but they can still nonetheless appreciate colour. But rather than seeing in three colours like we can, then they actually have a world which is more two colours. But it's not black and white. They can appreciate colour, but it's not the 3D type colour that we would appreciate. They've got a slightly reduced range of colours that they're capable of seeing.
Essentially a bit like a colourblind human, in that you don't have that full range that we would normally have. They do also have more of these light-sensitive rod cells, so they can see in lower light levels than we can. I think probably not as many as an animal like a cat, which relies on hunting at night, but they certainly can see in much, much lower levels than we can.
And one other cunning thing that dogs and cats do, and anything that's awake at night, anyone who's ever shone their torch at a dog in the dark will notice that the eyes glow. And the reason the eyes glow is because on the back of the retina is this special structure called a tapetum lucidum, which is Latin for bright carpet. And if you dissect an eyeball from an animal that is awake at night, you'll see this area at the back of the eye which is bright and shiny like mother of pearl. And it behaves like a mirror. So when light goes into the eye, it's focused onto the retina, the light-sensitive part that turns the light waves into brain waves. Any light that misses the retina goes to the back of the eyeball, bounces off this shiny layer, and then goes back past the receptor cells for a second go at being detected. And so this means that the dog or the cat or the bat, lots of animals that are awake at night use this, they have much more acute night vision because they're able to use the light twice. The problem is that the light doesn't necessarily hit the retina at the same angle it should have done, so there is a blurring, so they don't see quite as well as they would do, but they nonetheless see a lot more than you or I could in the dark, because we don't have this structure. But that's why your dog's eyes glow demonically in the dark when you shine a torch on him.
Mine do as well, demonically. Thanks very much, Luke. Tabo, Costas, Kumbuzo, Walter, I see your calls and all these SMSs. I'm going to accommodate you to the best of my ability. But first, let's get the very latest Eyewitness News headlines with Bobby Brown. Good morning.
Really good morning. I wonder if I'm allowed to ask the Naked Scientist a question that I'm sure will stump him.
Yes, go ahead.
The question is quite simply, what don't you know anything about?
Don't know. That's a way to think about that one.
You were right. You were right.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
28 minutes to 10 o'clock. I'll tell you what, Costa and Skumbuzo, just hold on for me, because we have a 12-year-old who's in the studio. His dad sent me a tweet. Is it a tweet? I only started tweeting 4 weeks ago, so I'm still learning the language. So your dad sent me a tweet that you'd like to meet the Naked Scientist. How are you, Gwanda?
I'm good, thanks, and you, Reedy?
Fine, thanks. How old are you? 12?
I'm 12, yes.
That's grade?
7.
Grade 7. And you love science, and what else do you like?
I enjoy sports like soccer, golf, squash. I also enjoy maths, English, history and geography.
That's fantastic. And which school do you go to again?
I go to Bolu Preparatory in Midrand.
Okay. And how did you know about the Naked Scientist? Because he's always on at 9:30 and you should be at school.
Yes, I am at school, but my parents, they do listen to him when they're at work or on their way to work. They tell me all about him, and my mom got us tickets to watch him tomorrow.
That's fantastic.
At St. John's. Yeah, so my dad organized this so that I could meet him in person.
Lovely. So what's your question for Chris?
What makes the sky blue?
Okay, can I just say, you need to give this guy a job in radio.
I know.
He's better than I am.
I know.
It's fantastic.
Wonderful.
Great to meet you.
Thank you.
The answer is that if you look at the sun, it's producing many, many different colours of light, which when you look at them together look white. Because there's lots of different wavelengths of light, colours, which when mixed together look white. But when they reach the outer part of our planet, where the atmosphere is, they hit the atmosphere, and the atmosphere contains a lot of oxygen, about 20%, and nitrogen, 80%. And the molecules of oxygen, that's 2 oxygen atoms stuck together and 2 nitrogen atoms stuck together, the bond that connects them is about the same size as the waves of light that are blue. Very short wavelengths. So when those blue waves of light come into the Earth's atmosphere, they get scattered by the atmosphere. But the longer wavelengths, the reds and the greens and yellows, they go straight through. So when you're looking at the sky, what you're seeing is the sun up in the sky, and it looks a bit yellow, because if you take white, which is the white light, and you take a little bit of blue out of it, it looks a bit more yellow. So that light has come straight through the sky towards you. But the blue light, which has been scattered by these bonds in the oxygen and nitrogen, your eye sees it coming from all over the sky. So it looks to your eye like the whole sky is blue, because there's light, the blue wavelengths, coming to you from all directions. We know the sky isn't really blue, because as soon as it gets to night time, what colour are the stars? They're white again, and the sky looks black. So it's just an optical illusion, because the atmosphere scatters the blue light all over the place, but the non-blue light comes straight through to you.
Are you happy with that?
Yes, thank you very much.
Fantastic. I'm going to give you a chance to take a picture with the Naked Scientist in just a moment. But first, let's just go to somebody who's been holding on for a very, very long time. Costa in Sandton.
Hi.
Hello. Can you speak up, please, Costa?
Yes, can you hear me?
Yes, indeed.
Okay, hi, Chris.
Hi, Costa.
The question I have is based on M theory and its predecessor, the string theory. We're told that everything emanates from a vibration caused when you pluck a string, and it's actually in a sound wave. And then it travels as a sound wave, and it emanates only when it's observed. Now, my concern here is what comes first, the observer or the observed?
It sounds like a philosophical question. In either case, either string theory or philosophy, it's not my strong point, so I can't really help. But are you asking me, is this the question like if a tree falls over in the forest, if no one's there to hear it, does it make any sound? Sorry?
More like the chicken and the egg, what comes first?
Yeah, I thought so.
Yeah, well, I really don't know, is the answer, because I'm not a string theory expert. Not really an expert on anything. But all I can say is I do know some mates who are very good. And if you want me to, I'll go and talk to them and try and get you an answer to that. Because we can get the question, we'll record it off, and I'll put it to someone who I know is an expert on this, and we'll see what we can do for you. But I can't answer that, I'm sorry.
All right, Costa. We'll see if we can get an answer. Let's go to Thabo in Soshanguve. Hi.
Hi, really, these kids are becoming too smart for my liking.
They're becoming too smart.
For my liking, I'm telling you. This one just asked me now, help me look smart. He's asking, why is it that when you are in a convertible and you throw something up, it doesn't remain at the back, it just moves with you. Like when you are in the train and you jump up, a moving train, you don't remain at the back, it just will be there. Then my second last one is my nails. How can I make them not grow at all? I mean, I hate that when they grow. Is there something I can do for that? Yeah, I mean, really, I hate cutting nails all the time.
You've got big problems,
Okay, well, let's look at the first question, which is, if you're driving along in a car or a bus or a train and you throw something up in the air or you drop that thing, why does it fall straight down? Why doesn't it get left behind in space and end up at the back of the car or the back of the bus or the back of the train and so on? And the answer is that it has momentum. Because you're holding that object, the train is moving along, the train is making you move along, and anything you're holding is moving along too. Therefore, it has momentum, velocity, in a direction that you're travelling in, and when you drop it, there is no force acting on that object apart from gravity to move it in any one direction apart from downwards. So it just falls straight down, because relative to the train or you, then it is not actually moving in any direction. So gravity just pulls it straight down, and that's why it falls straight down. The second question was about nails and toenails, fingernails and things like that. They grow at several millimetres. I think it's about 10, 15 centimetres a year, I think, is nail growth rates.
It's roughly the same rate as continental drift as well.
Yeah, so America and England are moving apart from the mid-Atlantic ridge at the same rate that your toenails grow. What actually are toenails? Well, they're made of the protein keratin, the same stuff that a rhinoceros's horn is made from, and the same stuff your hair is made from. It's a very tough, fibrous protein, and it's produced by cells in the nail plate, which make this protein and weave together these strands of protein to make this tough, fibrous material. And the nails are merely made at the rate that the cells are turning over. So anything that makes the cells grow more slowly will slow down nail growth. And so people who are malnourished, if they don't have enough calories and don't have enough protein in their diet, their nails will become weak and will grow more slowly. Anything that damages cells that are growing very fast will also slow down nail and hair growth. So when people have a chronic illness, and especially if they have a cancer and they have chemotherapy for their cancer, which targets cells that are dividing very fast, then nails stop growing and hair stops growing or falls out altogether. And you'll also notice when people have this, you'll get a ridge in the nails. You get this line forming in the nails. And it's almost like a tide mark, which as the nail and the person recovers, you'll see this tide mark grow out in the nail. And it's where the growth plate has arrested or stopped growing for a little while the person was on treatment.
Okay, Tabo, did you hear that? You need to stop eating so that you are malnourished. I'm not sure if you are prepared to do that. Then your nails will stop growing, but you must remember other things will stop growing as well. Let's take a break. Kumbuzo, Walter, Bruce, I see your calls right after this.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
Alrighty, let's go to Bruce in Victory Park. Good morning to you, Bruce.
Good morning. I'd like to ask the professor how to speed up dissociation of hydrogen and oxygen in water.
I've been promoted. I'm a professor now. I like that. You can come to England and tell Cambridge University to give me a professorship, Bruce. That'd be good. Good morning.
Okay.
I'm not really clear what you're asking. So when you say dissociation of hydrogen and oxygen, are you talking about splitting the water molecule, H2O, apart?
Separating the atoms.
What do you mean as in doing it electrically?
Yes, electronically.
Okay, because when you take a solution of water and the water molecules are as H2O and you pass an electric current through them, then you can apply enough current to actually break the bond which is between the hydrogen H and the oxygen O. If you supply enough energy from the electricity, you can break that bond and you add some electrons to the you add some electrons to the hydrogen ions and you make H2, hydrogen gas, and you take some electrons away from the oxygen to make oxygen, O2. There's no way of making it happen any more easily. The energetics of that equation are driven by how strong the bond is between the hydrogen and the oxygen, and you have to supply enough energy in order to overcome that bond. And there's no way of replacing, there's no free lunch. You have to put in the same amount of energy that it takes to break that bond. In fact, if you then burn the hydrogen and oxygen, you will have to waste some energy because you will not get all of the energy you put in back again, because there's no such thing as a 100% efficient process. But that's how it works.
Okay.
I think the only way you could do that would be to look at your electrodes and increase their surface area dramatically. So
it's still going to take the same amount of energy, though.
The same amount of energy, but you could do it quicker by having more surface area on your electrodes. Again, you'd need to put more energy in because you'd be breaking more bonds at any one given time. But if you just have two very simple sort of pencil-like electrodes and the actual contact between water and electrode is at a minimum, whereas if you have something that's very finely branched, maybe even at a nano scale, so getting into nanotechnology, then you can have lots of contacts between electrode and water, and that increases the opportunity. But as Chris said, the rules with the energetics are fixed. You need to put more energy in to break more of those bonds.
What people do though is sometimes add some acid, usually sulfuric acid, to the solution, and what that does is to ionize the water more. So you've got more H plus ions and some sulfate ions, and they carry the electricity through the solution, and that makes the electricity flow more easily, because water is very, very poor as a conductor. Everyone thinks water's a really good conductor of electricity, but it's not. It's really poor. So if you add something with some ions in it, like sulfuric acid, then it actually carries the electricity better through the solution, and it will be a bit more effective.
Walter in Pretoria. Thanks, Bruce, for your question. Walter?
Hi, Reedy. Hi, Dr. Chris. My question is, actually, I just want to find out, why is it that when I sleep with the electric blanket on, in the morning I tend to be very, very, very tired? And is it very safe to use when I sleep with an 8-month-old baby?
Oh, okay.
Hi, Walter. Yes, as someone who's occasionally used an electric blanket in the past, when I lived in somewhere that was very, very cold, my house was very, very cold, I didn't have that problem because I did actually get a good night's sleep. But it might be, are you leaving the electric blanket on all night? Are you getting too hot, do you think? Because one of the reasons for waking up not feeling very well rested is because although you think you've been to sleep all night, you've periodically kept waking yourself up to roll over or push the blankets down, pull the blankets back up when you get cold. So is it that you're not actually getting a good night's sleep because the temperature is wrong? Do you need to sort of warm the bed up with the electric blanket before you get into it, and then turn it off?
What I do, I put it on a level of 3, then I put it back to 1 when I go to sleep.
And it's on the whole night?
Yeah.
Yeah, see, I would worry that you're getting a bit too hot at certain points in your nighttime sleep cycle, and as a result you are waking up a bit, rousing yourself without realizing it, and this is meaning that you don't get the full cycle of sleep, because if you watch what happens when someone goes to sleep, sleep isn't just switching off your brain and resting it for 8 hours or however long you sleep for. It's actually a process where you go through different phases of sleep where the brain is inactive, then it becomes very active again for a little while, and that's called REM sleep, or rapid eye movement sleep, and that's when you're dreaming actually. And those phases change in length as the night goes on. The REM sleep gets longer and longer as a proportion of sleep as the night goes on, and you need all of those phases to work properly in order to feel rested. And if that doesn't happen because you keep on being woken up by being too hot, for example, you will feel really tired the next day. So I would try, if you can, turn the electric blanket off altogether one night.
And is it safe for the baby?
Well, babies are pretty good at regulating their body temperature because they'll just wake you up if they get too cold. And the other reason is that most parents who have babies complain they never get any sleep anyway. I certainly don't. My son's three years old and he's still waking me up every night in the middle of the night. I'm actually quite enjoying being here in South Africa because actually getting some more sleep.
How's that for honesty? Skhumbuzo in Davidton.
Hi, good morning everyone.
Fine, thanks.
Fine, thank you. I actually had a question about blood, but I've got another interesting one. According to Albert Einstein, the way gravity works, he demonstrated it by holding basically, let's say, like a blanket, two people holding a blanket and putting a heavy object and sliding other objects. That's how the planets are orbiting and everything. But if I would do that, generally the smaller object would end up hitting the heavy object if I would do that, demonstrate that. So why hasn't the planets moved closer to the sun? Because there's proof that the universe is actually expanding. So why haven't we moved closer and actually touching the sun? Because it's been happening for millions and millions of years.
We get the question. Ben, do you want to tackle that?
It's a good question.
It is a good question, actually. One of the things that people don't really realise is that of the different forces we're aware of, gravity is actually very weak. And in many ways, we are actually slowly moving towards the sun. But because of the way that the solar system was created, we have this leftover energy, this momentum, that actually means that we've just got enough energy to keep going in a circle around the sun rather than just quickly spiral into the sun and get eaten up, as it were. And the same goes for all of the other planets. They've still got this leftover energy from all of our planets in the solar system, came from essentially one spinning disk of gas and dust and that sort of stuff. The sun coalesced in the middle, but we still had enough energy in that spin to mean that we don't quite fall in. There are other interesting things going on with other bodies. For example, the relationship between Earth and the Moon. We're actually what we call tidally locked, and that means that the Moon is actually stealing a bit of energy as it goes round, and because it's getting extra energy rather than falling in towards Earth, the Moon is actually getting ever so slightly further away all the time.
One interesting thing you could add to this, which makes it quite easy to understand, Isaac Newton, a few hundred years ago, did a thought experiment and said, well, if I had a big gun and I fire the gun not very hard, then the cannonball comes out and it's being pushed along by the gun, but also it's being pulled towards Earth by gravity, so the cannonball will come out and slowly fall towards the ground. If I fire the gun a bit harder, then the cannonball will travel a lot further before it hits the ground. Are we all in agreement so far? Yeah? Well, what about if you fire the gun so hard that actually the cannonball goes along, but by the time it actually tries to land, the Earth has curved away under it, so that as the ball falls towards the Earth, actually the Earth is curving away from the ball. So at no time does the ball ever get close enough to the Earth. It's continually falling towards the Earth but never hitting it, and that's what an orbit is. Basically, something is travelling so fast that although it's continuously falling towards something, the thing is falling away beneath it faster, or as fast as it is falling towards it. So it's in orbit. And so our planet is in orbit around the Sun, where the Sun is pulling us towards you by gravity, but all the time the Earth is falling towards the Sun but missing. In the same way as Isaac Newton's notional cannonball is always missing the surface of the Earth because it was going so fast. If we slowed down, then we would eventually be overcome by the Sun's attraction and we would fall into it. But we have enough momentum, as Ben says, that we don't do that.
Skhumbuzo, thank you for that question. You must call us again. I have an SMS here. It's just disappeared from my screen, but somebody wanted to know how sperm stays alive when frozen. What's the science behind that?
Okay, well, The sperm are made in the testes, of course, and they're actually stored inside the human body for quite a while, because you make the sperm in the testes and they're made outside the body because they're actually made optimally. In other words, the best temperature to make them is actually just below body temperature. So once they've been made, they're then moved inside the body and they're stored in a structure called the seminal vesicle until they're needed. But because they're single cells, when you remove them from the body, you can actually add to them something called glycerol. And glycerol is just a sugary alcoholic molecule, and it can stabilize the membranes of the sperm, and you can then put them in liquid nitrogen at minus 200 degrees. And because the proteins and the membranes are stabilized by things like glycerol, then the sperm cells go into a state of suspended animation, because when you freeze things, the reason things don't survive freezing very well if you don't take steps to stop them being damaged is because the water that they contain, and it's worth bearing in mind cells are 80-90% water, the water will form little ice crystals, and the ice crystals will puncture the membranes of the cell and rip holes in it. So when you then thaw them out, you have just this thing which is just a bag that's a bit like you taking a balloon and making millions of holes in it. It won't blow up anymore, so it just falls to pieces. Whereas if you stabilize the structures with molecules like glycerol, then actually what you do is make them freeze really well. Not actually stop them freezing, but make them freeze really well. And you make them freeze in such a way that the crystals form in one nice configuration, locking everything in place without being all jagged and making holes in things. So when you thaw them out, they then come back to life. Much harder to do with a strawberry, though, which is why no one's ever solved that one.
It's impressive that this works for the single cell unit that is the sperm, but there are actually species living in polar regions where their entire bodies can freeze, and it's through exactly the same mechanism. They have a natural antifreeze in their tissues that stops these ice particles from forming. So there are fish, for example, and there are various different marine species that can totally freeze and then thaw out again and carry on as if nothing happened.
Actually, it's not antifreeze so much as a pro-freezing thing. It's a chemical that makes them freeze really well, because that way they then actually produce lots of ice crystals, because the reason cells die when you freeze them, the reason this normally goes really badly wrong, is if you make an ice crystal in a cell, you consume some of the water in the cell because the water freezes first, and this leaves a strong solution of salts in the cell. Then water from outside moves in by osmosis and dilutes out the strong solution inside the cell, which grows more ice, which blows up the cell more, but leaves more salt solution behind, so more water comes in, and it blasts the cell to pieces. So if you actually make your cell freeze really well, really quickly, it stops this process happening before the cell swells up too much. So these frogs and things that can be totally frozen actually have a pro-freezing agent in them. Other species of animals, like there is an Arctic snow flea that you're talking about, Ben, that lives in Canada, they can actually stop themselves freezing at all down to minus 40 degrees. And in fact, people are looking at them as the way to get really smooth ice cream, because the chemicals have got proteins in them that stop this freezing process. And if you add those chemicals to ice cream, instead of having big, gigantic, jagged crystals, which is what makes ice cream all crunchy and not very nice, you get lots of tiny, smooth crystals, which makes ice cream taste really nice. So by borrowing from biology, you can actually make better ice cream. And Unilever are doing exactly that. They're using these chemicals from these tiny organisms as well as fish that can survive being at very low temperatures in the Arctic.
Yummy. Let's go to, is it Frida in Hurlingham? Hi.
Hi. I'd like to know, is the static in clothing and blankets and things harmful? You know, when we get dressed, we see all these sparks going off.
Okay, Frida, thank you very much.
Well, it's not harmful with regards to doing damage to people, but I was fairly certain that I'd broken my hotel room key the other day, because obviously it's got a magnetic strip down the side, and I went close to the door and this huge spark jumped off the metal
It's your
of the door
electric
handle.
personality, Ben.
Yeah, it must be. So it's not harmful at all.
Well, they're actually very, very high voltage, but the current is so small that it's not actually going to do any damage. But you need a very high voltage. It can be very painful.
The one time it can be harmful, though, is accidentally if there's a gas leak. And you then create a small spark, because a spark is actually a really high temperature. That spark is at thousands of degrees, just in that tiny bit of air that you're sparking in.
Wow.
And because the spark is so tiny, then that energy is dissipated very quickly, but that patch of air will get very quick, so it's well beyond the ignition temperature of gas. So if you have a gas leak, and there's a mixture, therefore, of gas molecules and oxygen, the oxidant, then that spark is perfectly capable of detonating that thing. And this happens occasionally in petrol stations, because in America, they had quite a big problem with people, because in America you can fill your car up. You put the nozzle into the tank, and you pull the trigger, and you can tell it to just fill up, and you can just stand there doing nothing. And they found they were getting lots of fuel tank fires, and then investigation showed it's actually more common in women drivers than male drivers. And it turns out, if you watch what happens, women, more often than not, put the filler into the nozzle of the car, turn it on, they get back in the car to then go and get their bag, which is where their purse is, which is where their money is.
Yes.
So in the course of getting back in the car, they slide across the car seat, creating some friction between their nylon underpants, no, I'm just kidding, between their trousers and the car seat, and this gives them static charge. They then get out of the car, they go back to the fuel filler, which is earthed, and they get a spark, and the fuel gases that are coming out of the tank as it fills ignite, and then you get a fuel tank fire.
My goodness.
So actually you can do damage with static, but
women
the
are
stuff
powerful.
you pick up from the carpet,
That's all I read from that.
don't slide in and out of your car, and don't wear slinky underwear, because it will start charge you up statically.
All right, but Frida, rest assured you're fine. Let's go to Pam in Modderfontein. Hi there, Pam.
Hi, Reedy. Hi, Chris. Thanks for a great show. My question is, why is there a difference between body weight before and after showering?
I didn't know there was.
I didn't know, but I've heard this.
Do you gain weight or lose weight then?
Gain.
You go, how much?
About 150 grams.
Gosh, that's quite a bit. I thought you were going to say you lose weight, because then I was going to accuse you of doing what many people do and deny, which is to pee in the shower. Because, of course, if you pee out 100 mils of fluid, because your bladder volume can be up to a litre, most people pee 300. Then if you'd lost 300 grams after your shower, you say, well, you've had a wee in the shower. The only reason you'd gain weight is just because parts of you are wet, because although the skin is a pretty good barrier, it will soak up a bit of water from the shower and then dry it out again later. That's why your fingers go all wrinkly in the bath, because water has moved into the outer layers of skin and made the cells swell up. There's dead, flat cells in your outer layers of skin, and when you immerse them in water for a prolonged period, the water goes into the cells, swells them up, and they buckle, a bit like railway tracks on a hot day if you don't have a gap between them. And as a result, you are taking on a little bit of water, and that could make you a bit heavier, and your hair's going to be wet too, so that might be the reason.
Pam, stop weighing yourself so much. You're wonderful. You're fine, man. All right, so tomorrow at St. John's, what can we expect, Chris?
Well, it's going to be an explosive show, and hopefully Franz from Afrox, who are helping us out with our gases for our show, will have come up with the goods, and we'll have a special bit of kit to go on a cylinder of hydrogen, because we're going to blow some stuff up in a very big way. And we're going to turn hoovers, vacuum cleaners, into lethal weapons and put things into microwaves you should never put into microwave ovens. It should be an explosive and fun show.
Don't try any of that at home. And Ben, you're looking forward to that as well.
I am very much, yes. It's always great fun. It means you get to play with stuff that you shouldn't really play with, but actually...
Look at how they're smiling with the glee in your eyes. You get to play with things that you shouldn't be playing with. Well, welcome to South Africa. We're looking forward to tomorrow, and it's going to be fantastic. And we still have so many of our listeners who are disappointed because they didn't get their tickets. I told you to rush to CompuTicket. But nonetheless, tomorrow, those of you who got in, congratulations to you, and give us some feedback on Monday and tell us what it was like. What are you guys having for dinner?
Are you offering? Are you buying?
Yes.
Cool.
Wow.
What do you feel like? What do you feel like?
Curry?
Curry.
Yeah, good curry would be good.
I'm sure we can work that out, and the weather is favorable as well.
Excellent.
Lovely to have you here.
Right,
thank you so much. You have no idea. You know, Mava, we've been doing the show with Chris for 3.5 years, you said.
Yeah, 2007 we first met. This year, but 2007 we first met, and we actually first started doing this in January 2008.
Yeah. And you know how every week we commit to printing the SMSs or saving them for the next week? I don't know what we should say. No, I don't know what we should say today, because I don't know whether it's the fact that you are here, you are present here, or it's been an hour. The Cape Talk, the 702 SMS line, there are just so many SMSs. We'll see what we can do. We'll pick some of them up during our diary meetings, and some of them have been answered. We'll work through them, but I'm not committing to answering all of them. So please bear with us there.
Oh, good. You'll be here for a while.
Thank you very much, Chris. And
thanks, Reedy. Thanks for having us, everybody.